For those of you who don't know me, my name is Ted Neward. I've been doing a lot of things across a lot of different environments for many, many years. And it's actually worked out fairly well for me. As you can tell, I've spent some time over in the Microsoft part of the world. I've spent some time over in the Java part of the world. As a matter of fact, at one point at a conference probably about 10, 12 years ago, a buddy of mine who was introducing me at the talk said, "So Ted, you know, you're kind of a Java guy, you're kind of a .NET guy. Which one do you love the most?" And I said, "Chris, do you have children?" And he said, "Yes." And I said, "Great. How many?" He said, "2 boys." And I said, "Great. Which one do you love the most?" And he said, I get it. You love them both the same." And I said, "No, actually I don't. See, I too have 2 children. I have 2 boys. They're not really children anymore. They're 23 and 17. And Michael, my eldest, is a geek. There is just no way around it. He is a geek. He is scrawny. He is pale. He is up until 4 a.m. on Skype with his friends playing Dungeons and Dragons. I love when we take a social in-person game and do it over a remote telecommuting technology. That's just awesome. My youngest, on the other hand, Matthew is 17, and he is, well, he's a jock. He's actually taller than me. He's broader than me. He plays football. He's in the band. He's everything in many ways that his brother is not. Now, the truth is, I love them both, but I love them differently. I love them because they are different people. I love Michael because he and I can sit down and talk about programming and technology and whatnot. And I love Matthew because we can talk about playing in the band, we can talk about playing sports, et cetera, et cetera. It's not that I love one over the other, it's just that I love them differently. And that has been a significant hallmark to my personal career for a number of years, for almost 25 years now. So Devox asked if I would give a talk on this particular topic earlier this year, and I said, "Sure, why not?" And they said, "What do you want to call it?" And I said, "Polytechnical Careerism." And Stefan kind of blinked and then said, "Okay, what the hell is that?" And I said, "Oh, it's very obvious. It's how to manage a career as a polytechnical." And he said, "Okay, great," and we just left it at that. When I say polytechnical, I'm actually referring to 3 different things. Most of you are familiar with the term polyglot, right? This is what you call somebody who speaks multiple languages. Just out of curiosity, does anybody know what you call somebody who only speaks one language? American. Yes, thank you. Absolutely. Way to ruin the joke there. Anyway, a polyglot is one who speaks multiple languages. Polypraeclusio is making use of multiple storages, aka databases for our purposes. And polycrepido is multiple platforms, foundations. I'm borrowing liberally from the Latin here. When you are a polytechnic, you have a slightly different view on the world than many of your compatriots and colleagues. For example, how many of you would raise your hand if somebody asked how many of you in the room are Java developers? Fair number of us, right? It's really, really common for us to put an adjective in front of that. As a polytechnic, I don't. I'm a developer. That's it. I'm a developer. I will use whatever tool seems most appropriate to the job. I will use whatever storage system seems most appropriate for the problem. I will use whatever platform, whatever language. I will use whatever is available to the best of its ability for a given project. I'm very communist in that respect. Mr. Marx had a great quote. It's been paraphrased slightly, but I'm pretty sure that's the original. "From each technology according to its abilities, to each project according to its needs." It lost a little in translation, is my understanding. You really don't, when you're polytechnic, you really don't embrace the idea that there is one solution for everything. And yet, somehow, that always seems to be the case whenever we come up with a new thing. Right now, the hot new thing is, of course, JavaScript. Everybody wants to do JavaScript everywhere. It has to be JavaScript all the way down, et cetera, et cetera. That's great, except where it's not. There's almost always a part in any given platform, any given language, any given technology, where things don't quite work as well as we would like, and this is where having a different perspective can be particularly helpful. The problem is that it's kind of hard to do, because if you think about it, if you've been a Java developer for 5 to 7 years, in many companies that's considered a senior Java developer, to then say, I'm going to turn around and I'm going to throw all of that away and I'm going to start learning Haskell. I'm going to go back to 0. I'm going to be a 0 years experienced developer. That's hard. It's hard for a variety of reasons. Number one, because 0 years developer tends not to get paid as much as a 5 to 7 years developer. And I don't know about you, but I like money. Is anyone in here who does not like money? Show of hands. Because those are the folks you want working on your open source projects, by the way. No? Nobody here? No? Okay, so everyone here is a fan of money. Awesome. That takes time. It takes energy. It takes a certain amount of strength, if you will, to say, I'm going to throw away that which I know, and I'm going to dive into something completely different. Plus, on top of that, if where you are currently employed is not interested in the thing you want to learn next, now there's a tension between time spent learning this new thing and time spent that you could be learning something that's directly applicable to whatever your company is working on. And in some cases, the things that you will learn will suggest approaches to you that are in diametric opposition to what you currently know, so it doesn't feel like any of this stuff would ever actually be useful. There's a bunch of scenarios that I can talk about in terms of problems that a polytechnical approach could help with. And I've got a bunch of examples here. For example, if you're working on a project where the logic that you're working on is changing on a routine basis, and by routine I mean every couple of months. If you're working for, say, Amazon, and you are working on the module that will calculate sales tax on a given bundle of goods, I don't know if any of you have ever actually tried to calculate sales tax for a modern e-commerce system, but it's actually not trivial. And sales tax, by the way, is different from VAT. Sales tax is what American federal governments and state governments and local governments will slap onto the price of a good just for buying it within their borders. And you don't get any rebates off of sales tax, by the way. And it's different for every city, for every state. It's different in different nations. If you're actually shipping across state borders, sometimes it applies, sometimes it doesn't. If you walk into a Subway and say, I'd like a sandwich, whether or not sales tax applies can depend on whether or not you're choosing to eat it here or take away. It is not a very, very simple problem. It would seem like it. Just take the price, multiply the tax, add that to the total at the end. And it changes. It changes every time the government wants it to change. So every couple of years, sometimes every couple of months, if it's really, really bad. How many of you want to be working on the same code module for the rest of your life? One guy down here, because he thinks that means he could never be fired. You're fired. There's actually a startup in Seattle, I forget the name of it, but they're literally a sales tax as a service startup. That's all they do is calculate sales tax, and you pay them a certain amount of money every month to calculate sales tax on whatever it is you're doing. In some cases, the requests that are coming are actually user-level requests. If you've ever built a user interface for a user, for some individual, and they looked at it and said, I think that button should be over there. and then that button should be down there, and then we should take this drop down and put it over here, and then make the whole thing pink. How long will that take you? And you're like, 6 months. 6 months for all of that. Because of course, you have to go through your full development life cycle. You have to rewrite the tests in order to make sure that the buttons work correctly. You have to rejigger some of the flow for the various session state because they're moving that list from one page to the next. And you're like 6 months, and they're like, no way. You're fired. We're going to go get somebody else who will at least pretend to do it in a week. User interfaces have this really, really big problem with them in that they involve users. And users frequently, as soon as they see something, they change their mind in terms of what it is they want. So what if we could give the ability to modify or at least extend, manipulate, etc., the user interface back into the hands of the users? Microsoft Office did this. Microsoft Office, with Word and Excel and Access, they built in some scripting languages that then was able to manipulate the object model inside the application, which then gave the power back to the hands of its users, so that if you wanted to do something that the core application didn't support, there you go. Take a little VB script, take a little object automation model, throw those together, shake well, boom, you have an application. Google Apps Script does the same thing. There is a company in, you're not going to believe this, but there is actually a town in Indiana, in the United States, called Warsaw. Warsaw, Indiana. It is home to a company that sells crop insurance, like farmer crop insurance. So if you're a farmer and your crops fail, they will, in fact, because the US government pays them a certain amount of money to subsidize this, they will pay you for when your crops fail. And they do a tremendous amount of mathematical analysis based on the size of your field, what you were planning to grow, what you grew there in previous years, current weather predictions, et cetera, et cetera. All of that is currently written as a set of Google Apps script in JavaScript living off of Google Sheets. Now, the developers in the room are like, tee-hee. They don't have any unit tests. They're so screwed. Except it's been working pretty well for them for the last 5 years. Before that, guess what they were using? Excel. Yep. In some cases, the problems that we deal with are complex permutations of possibility. If you've ever tried to schedule staff, like if you worked at a restaurant and you're trying to figure out, okay, I need 5 servers to work the 5 p.m. to 10 p.m. shift, and okay, well, Angie can be here, but she can't be here beyond 9 because she's got another job, and Joseph, well, he can only be here starting at about 4, and then Fred requested Wednesday off. There's all these possible permutations to solve the problem, and you're trying to build an online scheduling system that will capture all of this. This is not going to be easily represented in a series of if, else, or one big-ass switch statement. It's not going to work. At least it'll work for the first iteration, and then as various scenarios change, as it turns out you need 6 servers instead of 5, you're going to have to go back and you're going to have to refactor all of that code. And yeah, we can try to break it out into various strategy patterns and so forth, but it's still going to be a really tangled, convoluted mess, because what we are trying to do is we are trying to get the computer to perform logic. And there are languages that are actually deliberately designed to do logic. If you've ever sat down and done the Sudoku puzzle from your local paper, that is the kind of problem that languages like Prolog are extremely well designed to be able to solve, which you wouldn't know unless you were familiar with Prolog. And in some cases, the logic is best expressed by domain experts, people who've lived this particular industry. If you've ever tried to rent a car, you know, you go to Hertz, you go to National, you go to one of those companies and say, I would like a car starting on Sunday and, you know, returning on Friday. And they say, well, we don't actually have any cars available. What do you mean, no cars? Well, I mean, basically, that particular lot from that particular airport is sold out. And I'm like, really? Because I had this conversation once. I said, really? You don't have any vehicles because, how am I going to get from the airport to my hotel? And the receptionist on the phone said, well, okay, hang on. What time does your flight come in? And I said, well, my flight comes in on Monday at about 5 p.m. And she said, okay, here's what we're going to do. We're going to actually book the reservation from Sunday at midnight until you return to the airport. Then, as soon as the reservation is booked, I'm going to put in that this is a late pickup, which means you can pick it up anywhere up to 12 hours after the original reservation is supposed to start. Then, that'll actually be within the 6-hour window before they will release the car, so therefore, you'll have a car. I'm like, wait a minute. You don't have any cars, but somehow one will magically appear because you've got a 3D printer in the back or something? How? Well, because of the various business rules that was set up. And oh, by the way, this is actually going to be cheaper than if you had just picked it up on Monday. Can anybody make sense of this whatsoever? Now, I guarantee you that there is somebody at that rental car company who knows all of this stuff. They were there when those business rules were first enacted. They've been there as they've sort of lived through all of these various business rules that have been put into place and people have gotten accustomed to and so forth. And that person is not you, but you're the one who has to write the code for that online system. How about we just cut out the middleman? How about we create a tool, a language perhaps, that allows the subject matter expert to be able to do their own thing, to let them express it. Does it have to be a Turing-complete language? No, it really doesn't. This is the whole realm of the domain-specific language, and it was a really, really popular idea for quite a while. In some cases, the requirements that we want to deal with in terms of storage, they don't fit what we're trying to do. Imagine for a moment this conference. This conference had you register, and we've got your registration information, and it's got your name, your company, perhaps your address, your email, et cetera, et cetera. We've got all this information, and they want to store that. They want to be able to do queries, right? They would, of course, never sell your information to anybody. No, never that. But we also want to track the video of what we're doing here. As a speaker, I have a registration here, and so do we put the video into a relational database? Because if you've never tried to do that, really large binary blobs inside of a relational database does not work particularly well. Trying to do a query against the video column really just doesn't end well for anybody. But there are other storage systems, CouchDB, MongoDB, etc. They'll love binaries. If you wanted to build YouTube, which is literally nothing but a big database of videos, but then there's all those comments, and there's all these ratings, and there's all these channels, you start saying, gosh, what data storage can I use that would ever possibly be able to handle really big-ass binaries, but also be able to let me do some queries across the data in a structured fashion? And my response is, none of them. Use both. This is where you start leveraging the idea of collecting both together. Let's let a relational database do what it does well, that is, express relationships. And let's let something like Mongo or Couch or one of these other more binary-centric data storage facilities do what they do well, even if, frankly, we just fall back to the file system. Now we can get all kinds of gigabytes in the cloud, so let's just dump the video into S3 and then put the hyperlink inside the relational database and go from there and see how far that takes us. One of my favorite scenarios is, of course, and I realize this doesn't apply to you, because you are on a team filled entirely with all-stars, rock stars, ninjas, right? Right? Show of hands. I am a ninja, and all of my colleagues are ninjas too. Yeah, and the whole front row here, they all work together, so they're like, you better put your hand up. Yeah, I hate to say it, you're not a ninja. You're not, because I can see all of you. So if you were ninja, I would be lecturing to a seemingly empty room right now. And I see you. So you're not a ninja. And based on some wandering around last night near the conference center and the castle and in downtown Market Square and so forth, and none of you sing very well either. So you're not rock stars. But it is fair to say that some of you will have skills beyond those of your peers. And it is fair to say that it's entirely possible that you will encounter somebody who will work with you that actually may have some skills that you don't. This has been one of the great debates around language design. As a matter of fact, I was just having this debate yesterday as I got here to the conference. And the question was, when we start talking about programming languages, would you prefer to have a language that requires you to focus on some fairly straightforward and simple concepts, a la Java, or would you prefer to have a language that lets you do some really tricky and elegant stuff, potentially at the cost of being completely incomprehensible to other people within the company, a la Scala, Clojure? And I remember, I was relating this conversation, I remember sitting around with a number of other speakers about 10 years ago. We were at dinner and we were talking at that time about Ruby. And one of the things that some of the other speakers were saying is, oh, I love Ruby, it's got all this syntactic power, it lets you do some really amazing things. And I'm like, look, but at the same time, what are the chances that everybody else on the team is going to be able to understand that? I said, in some respects, when you're playing around with a language that, really lets you do some crazy things with the syntax, it's like you're juggling chainsaws. You guys know chainsaws, right? We use them in horror films. Right? You're juggling chainsaws. You can do some really amazing stuff, but if somebody's not a particularly good juggler, someone's going to lose an eye. And then all the fun is gone. That's what American moms, by the way, will say to their children. It's all fun and games until somebody loses an eye. Then you'll be sorry. And it was a really interesting discussion because several of the other speakers looked at me and said, yes, but I would much prefer a language that lets me juggle chainsaws because I know how to do it safely, as opposed to a language which constrains me from being able to reduce 15, 20, 50 lines of code down into 1 or 2. Because, number of lines of code actually does have a direct relationship on the maintenance of your code overall, et cetera, et cetera. Here's the funny thing. We all write code on top of a platform called the JVM. And the JVM actually doesn't care what you wrote your code in as long as it ultimately turns into a class file. And so if I've got a team with a wide, disparate variety of skills, why not let the experts write code in Scala or Clojure or their favorite language of choice and use it from a safer language like Java? Or even potentially now, thanks to the fact that Java has scripting engines that ship with the JDK out of the box, Nashorn, JavaScript. There's a lot of people who will listen to this and will say, no way. I'm sorry. This is a fever dream. This is a pipe dream. You cannot take people from such a broad technical background, throw them together in a room, and have something that works. And that's definitely not the case. Barack Obama, some of you may have heard of him. You may also be familiar with his successor, which we won't talk about. When Obama was getting ready to be elected, he specifically wanted to leverage technology. He specifically wanted to leverage the power of the internet. And so, like most campaigns, he called for volunteers, and he got a bunch of volunteers. There were a lot of people who were very excited to work as a part of his campaign. But they all came from very, very diverse technical backgrounds. There were some PHP folks, there were some Java folks, some .NET folks. And because this was a Democrat, leftist, there were even a couple of Pearl folks, and they didn't get turned away because, Democrats, they'll take anybody, right? Nobody laughed at the Pearl joke. That's a little disturbing. They took them all. They brought them together. They said, here's what we need to do. We need to create this nationwide, potentially global if you really want to think about it, because we've got a lot of Americans that are overseas in various capacities. We need a global, worldwide infrastructure, and we need it like yesterday, because the election cycle in the United States runs probably about a year in length, year and a half, if you could count the primaries and so forth. In 583 days, they designed, implemented, deployed, and dismantled 2,000 nodes processing 10,000 requests per second across 3 data centers, 180 terabytes, and 8.5 billion total requests. Start to finish, closed out, the whole 9 yards. And there was no global architecture here. Folks, 583 days, that's faster than what some system architects will take to produce a bunch of PowerPoint slides. All of that is very interesting, but it's very abstract. And it doesn't really necessarily get to what I think is the real heart, the benefit of being a polytechnicist. So let's talk about something a little bit more concrete. How many of you are familiar with Haskell? A couple of hands. Good enough, good enough. The rest of you are like, I've heard of it. I know it's a language. I know that really, really pretentious people enjoy programming in it, right? Because the functional guys, right, they will have a tendency to be very, very pretentious. It's all about monads and monoids and the subcategory of endofunctors and whatever. You have to have a man bun if you program in Haskell, by the way, just as a heads up. That is a list in Haskell. Everybody got that? Cool, we move on. There are a couple of things I can do with lists in Haskell. There are a couple of functions. Head will give me the first element out of the list. Last will give me the tail out of the list. By the way, the curly bracket dash syntax, that's the comment facility in Haskell, and that's just showing you what would be printed when you print this out. Tail will give me the remainder of the list after the head has been trimmed off, so we can see that tail gives me 2 and 3. And take says, let me return a list consisting of the first n number of elements of that list. So here when I take 2, I'm getting 1 and 2 out of that list of 1, 2, and 3. So far so good, right? Awesome. I can also create lists using the range operator in Haskell. So here, I'm creating a list of 1 to 100 sequentially, and I can even put some period into it. So for example, if I want only the evens, I can say, let me get the numbers 2, 4, and then Haskell will assume that everywhere from beyond that, I want basically the even numbers, increment by 2 instead of by 1. So this will give me all the even numbers between 2 and 100. Not bad, right? The other thing that Haskell can do with these lists is we can actually manufacture them directly out of code. This goes by the rather academic name of a for comprehension. Okay? So here, you can see that on the right side of that vertical bar, I'm basically using the left-hand arrow to take the elements of the list and pump that into X. What this means is Haskell will go ahead and iterate, if you will, over that right-hand side, and each time a new value for the list is called for, we'll get it from the code on the right-hand side there. Now here, you can see in squares, the second one, you can see that I'm doing the same, but then I'm actually saying x times x. I'm manipulating that result before I actually return it. And these will return what you would expect. The first one will give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The second one will give me 1, 4, 9, 16, et cetera, all the way up through 100. If you've ever been challenged in a programming interview, by the way, on how to do FizzBuzz, this is the very simple algorithm that says count from 1 to some number. And if the value is divisible by 3, print out fizz. If it's divisible by 5, print out buzz. If it's divisible by both, print out fizz and buzz. And here, it's a slightly modified version, but this is the exact same code, but it's all done in terms of a Haskell comprehension. Take the numbers 1 through 25, pump them into X, and then either keep X, or we're going to use BuzzFizz, or Buzz, or Fizz, or etc. At the end of the day, it's just code. It's looping, it's calling, and it's returning. Now, one of the things that Haskell will let you do is do what they call an infinite list. So remember our range operator from before, 1 ... means this literally never terminates. That list will in fact be infinite. And trying to print it, by the way, is a bad idea. Ask me how I know. There's even a method in Haskell called cycle, which will take a list and repeat that list ad infinitum. That is to say, it'll be a never-ending list. So here, what I can do is I can take 3 from the list forever love, and that will take the first 3 elements of that list love and love, love, love. Can't possibly imagine who would want an infinite list. That's just ridiculous. I mean, lists are collections, and collections, by definition, have a finite bounds, right? There's just no point to this. This is just silly. This is just functional, pretentious, man-bun-wearing programmers being excited about some ridiculous concept that nobody could ever really possibly use in practice. At least that was what I thought when I first found this in Haskell. And then I went back to Java. And I thought, you know, Java iterators are kind of interesting creatures. For a long time, they've lived in the shadow of the collections that spawn them. If I have an array list, then the iterator just walks across the array list. If I have a linked list, then the iterator just walks across the linked list. What would happen if I had an iterator without a collection? Because that's kind of what a for comprehension is doing in many respects. It's producing a value each time you ask for one. And so that's kind of like an iterator that knows how to manufacture the next value that you're interested in. There's not really a collection there. There's not really a list. It's just every time you need a value for the list, you go to the for comprehension and say, give me the next value. So, for example, if I really wanted to try to capture that concept in Java, I could create an iterator, or in this particular case, I'm going to create an iterable, and that iterable knows how to manufacture an iterator, and that iterator in turn knows how to manufacture an integer. Now, it'll keep track of the current count, because it needs to figure out what's the next value I'm going to give you. And, you know, in this particular case, I'll say that this is an even numbers comprehension only up to the value of 100, so that I can just, you know, has next will say, when I'm at 100, stop, right? Because again, infinite lists, those are silly. And then to use this, because it's an iterable, it knows how to manufacture an iterator, which means it can be used as part of the for each in Java. It's kind of interesting. This is a ton of code, though. I mean, it would seem a lot easier just to do a for I equals 0, I is less than 100, I plus equals 2, and go from there. That doesn't seem like we're really gaining anything, right? But if I start thinking about the idea of an iterator that doesn't have to be tied to a collection, the iterator just knows how to manufacture the next value. Again, that's basically what the for comprehension is doing in Haskell. It's just manufacturing the next value, or it's obtaining it from somewhere, even if it's not manufacturing it out of thin air. So what if I were to create an iterator of string that knew how to read from a file? In other words, I'm going to open up a buffered reader, right? I'm just going to put a buffered reader around whatever file I'm interested in, and then manufacture an iterator that will continue to read until there are no more lines left. Now, because of the peculiarities of how Java does iterators, we have to actually prefetch the first line in order to know whether there's a line there, so that has next can return true or false. But now I have an iterator that knows how to read a file, which means, again, for each. Now, granted, there's a pesky I/O exception you have to deal with here, but if you're like most of us, you'll just put that into an empty catch block and ignore it. Or better yet, you'll write it to the system log file and let the system administrator deal with it, because that's what they do. That's their problem. But the interesting thing about that is, if you start thinking this way, if you start thinking about iterators as being somehow separate from collections, that iterators can in fact manufacture the values that they're going to be interested in, then you start realizing that there is a lot that Haskell and the other functional languages can teach us. As a matter of fact, there were a number of people who had already picked up on that idea. A number of them work at Google. And inside of the Guava library, you'll find two classes, iterables and iterators. And they have a series of methods, including the aforementioned take that I showed you from Haskell, to just grab the first couple of elements out of a collection. The important thing to note about this particular file iterator example is you'll notice that the memory pressure here is nil. I can do this with a file that is 2 terabytes in size if I'd like, because contrary to the collection approach, which says I'm going to slurp the entire file into memory and then give you an iterator across that, this iterator says I don't need a collection. I know where to go get the data in question, so I will go fetch it on demand as necessary. And once we start putting some of that intelligence into these iterators, we start opening up a whole bunch of interesting ideas. Such as, for example, I could maybe do some of the processing that I'm interested in doing. I could actually put that processing inside of the iterator itself. And then, actually, if I do that, so that I don't have to create a for loop to manipulate it, if I put the actual action that I want to do, the system.out.println from my earlier examples, if I take that and put it inside of the iterator, then I don't really see the loop. And if that action is in fact what we call side effect free, if I'm not manipulating any state from inside of that, then actually I could potentially take that processing and run it over a whole series of threads in a thread pool. Java 8 introduced lambdas, but more importantly, it introduced the streams package. The streams package is effectively this concept of iterators without collections, without having to deal with some of the pain of writing it yourself. Think about those infinite streams for a second, though. You say to yourself, there is no case where I would ever have a collection that was infinite. There's nothing that's infinite on planet Earth, period. Not the number of people, not the grains of sand. There's nothing that's infinite. What could I possibly model as an infinite stream? The problem is you're not thinking about the problem in the right way, according to some folks. You're thinking about it too temporally. That is to say, you're not taking into account time. What if we think about external events as streams? What if we start thinking about the idea of mouse move, mouse click, button click? Those are events. And we say, well, yeah, an event happens, and then we process it. What if you look at that as a stream of, collection of events that is in fact infinite? The user will never stop doing things, at least until the program crashes or you shut it down, which is basically the same thing for all intents and purposes. Or you're building a web application that wants to receive notifications from the server. Hey, somebody just changed the amount of something that you're interested in, the number of books in the shopping cart, or the current sales tax rules, or whatever floats your boat. Those push notifications, they can arrive at any time So what if instead of trying to model this in this giant state machine, what if we see that as a stream? What if we see that as a sequence of events and we want to process them one at a time? Effectively, we want to start modeling it using this kinds of syntax such that every time we go back for the next line, that is to say for the next event, we block until that event is ready. And then you simply say, hey, on this block of code underneath, that's what we do in response to that particular event. If we put some code around the idea of taking one thing at a time off of the stream, you actually get really, really close to the whole reactive metaphor. As a matter of fact, that's basically the reactive metaphor. Congratulations. Now, for the simple price of sitting in this room for 50 minutes, not only do you know Haskell, but you can put reactive programming on your resume. Please don't. Yeah, don't. Okay, so assume you're convinced. Assume that you're saying, all right, there is value in studying things outside of that which I currently labor. How do I do this? Well, as an individual, what you want to be, if you're going to pursue this notion of polytechnical, is you want to be what the recruiters these days are calling a T-shaped individual. If you consider the horizontal axis, the number of technologies you're familiar with, and the vertical axis, your strength in them, they want you to look basically like this. You should have depth in a few areas, but you should have breadth in a wide number of them. I'm not saying that you all have to go out and become masters of Haskell and begin debating monads and monoids and endofunctor reactors and whatever that, Cleasley arrows and all of that stuff. In many cases, that's not going to be useful unless you get a day job programming in Haskell, in which case, then yes, you're going to grow your depth in that language. If you're going to stay where you're at, knowing a little bit of Haskell, knowing what its strengths are, knowing how it looks at the world, knowing that there is a flavor of Haskell that runs on top of the JVM. As a matter of fact, there's two. This can all be helpful if you run into a problem that Haskell would be really, really well designed to solve. But for the most part, what you're looking for here, for most of us, is breadth in areas that you're not familiar with, and depth in the areas that you are familiar with, or areas that you're really, really excited about. Part of what you want to do then is when you look around the technical world and you see something, you want to figure out where exactly this fits in the world. You want to create a personal ontology. You want to create your own categorization system for how you sort things inside your head. Personally, what I like to do is I typically will try to create a fairly simple, non-trivial project, depending upon the technology in question. Many people like doing the to-do list as a getting started. That's fine, but the to-do list is really just an exercise in simple CRUD application of things. It's not really going to allow something to shine. Create some problem for yourself. Maybe you have a CD collection and you'd like to be able to sort through it. Maybe you're one of those old school DJs. You want to do that for your record collection. Perhaps you're part of a church. Perhaps you run a softball league, whatever. Some problem that has some unique characteristics that you can solve using said technology. For JavaScript, for example, I actually built a convention, a game convention scheduling system so that people could say, I want to host a game on this day at this time, and other people could sign up for that. There's a certain number of limitations. I can only have X number of players. Players may need to be over the age of 21, et cetera, et cetera. That actually turned out to be a really, really good, groundbreaking project to figure out what was good and what was bad about doing the whole mean Mongo Express Angular node stack. It's got to be a project that's personal to you, though, because you don't want to be asking other people for business requirements when you're trying to figure out whether or not this works well with the technology. You want to pursue dissimilar angles. If you know Java, don't go learn C#. Seriously, I love the .NET framework, and if you want to go learn F#, which is the kissing cousin to Scala, You want to go learn an object functional language on top of the .NET platform, go do F#. Awesome, I'm totally behind that. Don't learn C# because it's basically just another kin to Java. You could go learn Kotlin because it's just different enough from your traditional object-oriented language, but if you really want to grok functional, go do a language that's functional only. Haskell, or there's an older predecessor called ML. That is a language that supports no concept of objects whatsoever, and yes, there is a version that runs on the JVM, so at least then you could keep your existing tool stack if you really like. That ML version, by the way, is called Yeti. Pursue something that's different. If you're familiar with relational databases and you know MySQL, don't go learn Oracle. Don't go learn SQL Server. Go pick up Mongo. Go get Couch. Go get something that's completely different from what you know. The differences here are what's going to be interesting, not the similarities. Create your own evaluation function. That project, that problem, that whatever, in order to be able to decide whether or not this thing is of use to me. Again, it's got to be something that's personal to you. And don't be afraid to turn away. I mean, I understand it. Everybody's really, really hot right now for Kotlin. Everybody's really excited about it. Kotlin got supported by Google, and that means something is important, and yeah, this is awesome. But you know what? If it's just not speaking to you, walk away. It's okay. It's your time. It's your life. It's your career. You have to choose where to spend it. Would you really be interested in learning some of those concepts if they're just going to dredge up painful and terrible memories of having to slog through something? When I was in university, I actually took a programming class that did C++, which I was really good at, and Prolog and Lisp. And Lisp totally kicked my ass. I could not wrap my head around those parentheses to save my life. I got straight A's on the C++ part of the course, and I got straight F's on the Lisp part of the course. The professor actually was concerned that I was dying or something. Because he's like, I've never seen anybody, that badly. Lisp remained a foreign space. I mean, every time somebody said something about Lisp, I made a joke out of it. You know what Lisp stands for, right? Lots of irritating, silly parentheses. That was my go-to joke. And then, probably about 10 years ago, because of the crowd that I was hanging out with, speakers and whatnot, people started picking up Clojure, started looking at it, started showing me some of the benefits. It's like, oh, now I begin to get it. Okay, but it took me 20 years before I could come back to it. If you are a dev manager, you want to embrace the T-shaped team. The broader your team, the more powerful they will be in addressing a wide variety of scenarios. So don't hire Java developers. Hire developers. As a matter of fact, if your team currently is working in Java, go out and hire a C# developer who's wanting to make the cut over. They'll talk to you about Link, they'll talk to you about Visual Studio, you won't have the foggiest clue what they're talking about, but the conversation will be valuable because you will discover that there are things in the .NET world that we are only beginning to discover in the Java world. And that will make your decisions around technology that much stronger. Establish formal dissent. Have you ever been in a room where your manager says, we are not leaving this room until we all agree on what to do next? Management by consensus is a manager's cheap out. It is the manager saying, I am afraid to exercise my power to move us past an obstacle. Dissent is healthy. Dissent is important. There are psychological studies that will show that unless somebody dissents, you end up creating this culture where everybody turns into carbon copies of each other, and you lose the ability to innovate. Designate one person to be the dissenter, the official dissenter, to say, you will argue with whatever we say. I tend to have that role in my family as well as at work. Set some non-business goals and constraints. It's not always about just the technology you use. You also have to relate it back to the company's goals. What are we trying to do? How do we make money? If you cannot answer, how does your company make money? You are missing out, and you are probably going to be in the next round of layoffs. What is core business? What isn't? Same thing. How do we make money? What exactly do we care about? And accept that you're not always going to be able to hire full stack developers. Pull in a DBA, teach them some programming. They won't be the best programmer to start. None of us were when we got started, but they'll have very interesting perspectives on what should be stored and what shouldn't. Pull in that JavaScript HTML nut who went to web design school, dresses in all black, has like 2 earrings in this ear, 1 ear in that ear, wears a man bun. Because he'll have some perspective on how we should design things, and that will in turn lead to some interesting implications around system architecture, et cetera. You do not want to hire the same person over and over and over again. Diversity, both in terms of racial and gender as well as technical background, tends to yield the best results. We're now starting to see some studies that justify that. This isn't easy. I'm not going to stand here and wave this really Pollyanna, it will all be amazing and you will all be brilliant and everybody will be handsome and, good. And that's not. It's hard because there will be pressures on you to sort of conform to the rest of the crowd. But it's worth it because if you have a broad selection of technologies, if for whatever reason the bottom falls out of the Java market, you have places where you can go as an individual. As a team, if you are a polytechnical team, you actually have options in the event that your boss comes and says, oh, yeah, by the way, we actually need to stop doing Java. We are completely moving everything over to .NET because our senior vice president just had this really, really important meeting with some folks, and now we're a .NET shop. Because to you, it's just technology. It's just a tool. You show me a carpenter who only uses his hammer, and I will willfully retract everything I have said here. In the meantime, don't be a hammer-only carpenter. See ya.